All right, we're going to take a look at 10.6 here. 10.6 is all about something called rationalizing the denominator. So a rational number, you may remember, a rational number is any number that can be written as a fraction with a real regular integer in the denominator. All right, b is an integer. And also, a is an integer. So a rational number is any number that can be written as a fraction of two whole numbers, two integers, right? So, any regular number is a fraction, such as 7, right? And 7 is technically 7 divided by 1. So that's a rational number. Any regular fraction, right, is a rational number. So this section is all about something called rationalizing the denominator. So an irrational number are things that can't be written as a regular fraction due to some sort of non-repeating pattern. So things like pi, right? It goes on forever. It doesn't have a pattern. Or you can also have things like the square root of 2, right? There's no way to write that as a fraction of whole numbers. It's a non-repeating decimal. It goes on forever, very similar to pi. So what 10.6 is all about is rationalizing the denominator. And what that means is we want to get things set up in a way that the bottom part of a fraction is a whole number. If you're trying to divide by an irrational number, like a square root of 2 or pi or something like that, it can be very, very challenging to use it in certain ways, essentially. And we'll see examples of that as we go on with the chapter. But for today, we're just focusing on the bottom part of fractions here. And the goal is we don't want any square roots or cube roots. We don't want any radicals in the denominator. So when you see that phrase, rationalize the denominator, it means get rid of your radicals in the denominator. Radicals in the numerator is okay. We can usually work with that. But if you're dividing by a radical, it can cause all sorts of challenges later on. So generally, when you see some sort of square root, cube root, any sort of root in the denominator, in the bottom of a fraction, we want to make it go away. And so we're going back to one of our chapter 7 skills here, the one in disguise, borrowing a phrase from my algebra teacher, Mrs. Craner, who I've mentioned before. She talked about the one in disguise, and that means multiplying by a fraction in order to change a fraction we already have. So like, for example, if we had this fraction, so this is an example here, 1 divided by the square root of 2, and we wanted to rationalize the denominator, then we could, I don't know why I drew that arrow there. Actually, second thought, I like the arrow. So we could take that 1 divided by square root of 2 and multiply it by 1. In this case, 1 looks a little funny. We're going to multiply it by the square root of 2 divided by the square root of 2. So what happens when we do that is when we multiply fractions, you just multiply straight across. So multiply the top with the top, multiply the bottom with the bottom. So on top, we get 1 times the square root of 2, which is just square root of 2. On the bottom, we get the square root of 2 times the square root of 2, or the square root of 2 squared. And just like we saw yesterday, when we have a square root and a square, they cancel out. So the square root of 2 squared will just leave us with a regular 2 on bottom. So 1 divided by the square root of 2 is the same thing as the square root of 2 divided by 2. And now we have a whole number in the denominator there. So we have rationalized the denominator. We started with an irrational number, the square root of 2, and by multiplying by this 1 in disguise here, right, this is just 1, square root of 2 divided by square root of 2. By doing that, we have kind of tricked the denominator into being a whole number, a regular number, in this case 2. So we've rationalized that denominator. So now let's start looking at some examples from the homework. So this section really is, hey, birdies, thank you. This section really is pretty much that straightforward. We've got some square roots or other roots in the denominator, and we need to make them not roots. So we've got a couple different tricks for that. So the first set of problems here, starting with number 31, is exactly what we just did. So number 31 says 1 divided by the square root of 3. So what can we do with that? My bird is only talking when I'm talking. I think she's really excited about math. Anyway, we can take that 1 divided by the square root of 3, and we can multiply it by 1. A 1 in disguise. In this case, the square root of 3 over the square root of 3, which gives us a square root of 3 on top and a regular 3 on bottom, right? Square root of 3 times another square root of 3. The square roots kind of cancel out. We're just left with regular 3. Regular old 3 there. And that's the answer. So we haven't rationalized the entire number, right? Because we still have a square root of 3 on top. But the denominator is rationalized. It's just regular 3. So we have rationalized the denominator there. Let's take a look at 43. 43 is another good one. We got a negative 6 divided by the 4th root of x. So this one is going to take several 1s in disguise, right? Because if we were to just take this, negative 6 divided by the 4th root of x, wow, that's ugly. Let me write that better. 4th root of x, there we go. And we were to multiply by the 4th root of x divided by the 4th root of x. Sorry, got my alarm there to keep me on schedule. Then on top we'll have negative 6 times the 4th root of x. On bottom, we'll have the 4th root of x squared. And so we're not quite rational yet, right? Because this is technically we've got x to the 2 over 4, right? So remember how we can take radicals and turn them into exponential form. That radicals show us a fraction exponent. So x to the 4th root of x is the same thing as saying x to the 1/4. And then we squared that, so now it's x to the 2/4. But it's still not rational, right? That's just the 4th root of x squared. We still have that 4th root in there. So what we're going to need to do is we're going to need to multiply it by 2 more 4th root of x's. And actually, let's just start over so I can show you how to do this in one step. So just multiplying it by 4th root of x over 4th root of x didn't quite get us where we needed to be. We still have this fractional exponent, which is a radical, and we don't want that, right? The whole point is to get rid of the radicals today. We don't want radicals in the denominator. So we start with negative 6 divided by the 4th root of x. And what we're going to do is we're going to multiply by x to the 3/4 over x to the 3/4. So in order to see it a little better, let's rewrite this in exponential form. So we have x to the 1/4 in the denominator there, right? The 4th root of x. We're multiplying this by x to the 3/4 over x to the 3/4. So what happens when we do that is we get negative 6x to the 3/4 on top. Root. Thank you. Oh, nope, she didn't listen. That's okay. And on bottom, we get x to the 1/4 times x to the 3/4. And when you multiply things together, you can add their exponents. So what happens when we get x to the 1/4 times an x to the 3/4? We get x to the 1, right? 1/4 plus 3/4 is just 1. Now we've got a regular x in the bottom. We've rationalized our denominator. So that's what you want to do. You want to undo the radical, right? So for square roots, it's easy. You just multiply by another square root, and you get square root of a squared, and it cancels out. When you've got something other than a square root, like in this case, we've got a 4th root, then you need to figure out, okay, we've got x to the 1/4. We need to get that 1/4 all the way up to a 1. So how do we get 1/4 up to a 1? We need to add another 3/4 to it. So that's what we did right here. We found a way to trick that denominator into getting another x to the 3/4. That way we got it up to just regular x. X to the 1/4 times x to the 3/4. 1/4 plus 3/4 is 1. 4 over 4, right, which is just 1. So we've got a regular rationalized x in the bottom. And anyone who has a lot of x's probably know they're not usually rational, but that's okay. That was a joke. That was not a math thing. That was a little joke there. And up top we still have, in this case, x cubed 4th root, right? X to the 3/4 is the 4th root of x cubed there. So, or you could just leave it as x to the 3/4. That's also fine. But I wrote it in radical form here because most of the problems in the book today are in radical form, so I figured I would just, keep it the same. But you could have also written -6 x to the 3/4 here over x. That would have also been a perfectly acceptable way to write this. The important thing is that there is no more radicals, no more fractional exponents in the denominator. The denominator is a rational number, in this case just plain old x. We've gotten all of our radicals out of the denominator. So 31 through 55 are just a bunch of problems like that. So let's look at the next group of problems, starting with number 59. 59 says, what is the conjugate? So that's the topic we talked about yesterday, right? Conjugate. So conjugate is when you have some sort of radical expression added or subtracted. So in number 59, we've got the square root of 2 minus the square root of x. The conjugate is the same phrase, but with the opposite sign. So we've got square root of 2 minus square root of 6 here. So the conjugate would simply be square root of 2 plus square root of 6. So when you have some sort of expression added or subtracted, the conjugate of that expression is the same thing, but flip the plus to a minus or minus to a plus. So that's what conjugate means. Why does conjugate matter? You might ask. Why? Okay, cool, simple enough. What is that good for? Well, let's take a look at number 63 to find out. So 63 wants us to rationalize the denominator of 4 divided by square root of 2 plus 3. So previously, we just had one thing in the denominator, right? Like square root of 2 or square root of 3 or 4th root of x. We haven't had anything added or subtracted. Now that we've got that plus 3 in there, we can't simply multiply by square root of 2 because that might take care of this, but then this 3 will get a square root of 2 and we still have that square root down there. So how are we going to get rid of this? We need to use the conjugate. So if we take 4 divided by square root of 2 plus 3, and we multiply by the 1 in disguise, we still got a 1 in disguise here, but it's the conjugate, square root of 2 minus 3 divided by square root of 2 minus 3. So up top, we get 4 square root of 2 minus 12, right? That's just square root of 2 minus 3 times 4. And bottom, sorry, gotta clean off my screen here a little bit. All right. Sorry about that. And on bottom, we end up with square root of 2 plus 3 times square root of 2 minus 3. So now we FOIL. You got to FOIL the bottom, right? Just like we always do when we have two binomials. Binomials is a term with two parts. We've got two binomials multiplied together there. You got to FOIL, right? So we practiced this yesterday a little bit. Yesterday we first introduced conjugates. Today we're actually seeing why they're important. So first is square root of 2 times square root of 2, which is just 2. 2, come on. 2, there we go. Outer is square root of 2 times negative 3. So our outer term is square root of 2 times negative 3. Our inner term is positive 3 times the square root of 2. And our last term is positive 3 times negative 3 for a negative 9. So check out what happens here. We've got negative 3 times the square root of 2, and we've got, right, negative 3 times the square root of 2, and we've got positive 3 times the square root of 2. Those cancel out, right? We've got, if we have a negative 3 root 2 plus a positive 3 root 2, that just brings us right back to 0. So those two, the outer and inner terms cancel out. So we end up with 4 square root of 2. My bird really liked that. She's like, yeah, cancel out. So we got 4 square root of 2 minus 12 over 2 minus 9, right? Because these terms in the middle cancel out. And 2 minus 9 is just negative 7. So we get 4 root 2 minus 12 divided by negative 7. And usually we don't like negatives in the denominator. If this was your final answer on a test or something, I would still give you full credit because technically it is correct. But usually we don't like negatives in the denominator. So we could write this as negative 4 root 2 plus 12 over 7. So we just move the negative to the top is all. So either of these two would be acceptable. In college, your math professor might prefer you to write it this way without the negative in the bottom, but really it doesn't matter. So there you go. And let's take a look at 71, right? What happens if we have an x involved? So that again, we will use the conjugate. So 71, x minus 5 divided by square root of x plus the square root of 5. So, again, let's multiply by the conjugate. So x minus 5 divided by root x plus root 5 times root x minus root 5 divided by root x minus root 5. Right? So this is just 1. It just is a 1 in disguise in order to help us out. So when you multiply by the conjugate, up top we get x minus 5 times the square root of x minus the square root of 5. And you can FOIL that if you want to, but it's not really necessary. It's not really going to help us any. Nothing's going to cancel out. So you can just leave it like that. Down on the bottom, we get square root of x plus root 5 times root x minus root 5. So it gives us x minus, so our top is still this. And our bottom, our first term is root x times root x, giving us just regular x. Our inners and outers cancel out. So that's the thing with conjugates. You don't even have to look at the inner and outer because you know they're going to cancel out. We're going to get a plus 5, a positive square root 5 square root x, and a negative square root 5 square root x. So our inner and outer terms just cancel out. That's the beauty of the conjugate. So you just really have to look at the first and the last for the conjugate because the inner and outer, the middle part, cancels out. So our outer, right? Square root of x times a negative square root of 5, and our inner square root of x times a positive square root of 5 are just going to cancel out. And then our last term for our FOIL here is positive root 5 times negative root 5. Will just give us a regular old minus 5. And hey, check out what happens when we did that. Conveniently, we can now cancel out x minus 5, right? Because we have an x minus 5 group on top. We have an x minus 5 group on top and an x minus 5 group on bottom, so those cancel out. And we're left with plain old square root of x minus square root of 5. So we've rationalized the denominator here by completely getting rid of it. Like technically it's a 1, right? Technically it's divided by 1, but we don't need that. So there we go. There's the answer. So again, we multiplied by the conjugate, divided by the conjugate. So we just multiplied by 1. We didn't actually change the fraction. We just changed how it looks. So you're always allowed to multiply by 1. So we multiplied by 1 in conjugate form right here, in case you can't see that. And by doing so, all of these square roots kind of sorted themselves out in the bottom. That's the great thing about the conjugate, like I said, is the inner and outer terms will always cancel each other out, and the first and last terms will square themselves so that you get rid of any square roots. So when you have a square root added or subtracted to something in the denominator, such as in 63 or in 71, you got to multiply the top and the bottom by the conjugate, and that will make your square roots either cancel out or square themselves. Either way, you don't have square roots anymore. So that's it. That's it for 10.6. The whole purpose of 10.6 is we've got some sort of radical in the denominator. We need it to go away. We don't want radicals in the denominator. So that's what 10.6 is all about. So hopefully that was helpful. Let me know if I can help with anything, and have an awesome Thanksgiving break.